This video is about applying the properties of angle pairs formed by parallel lines and a transversal. So yesterday we talked about different angle pairs that happen when we have a transversal intersecting two lines. Today we're going to use those relationships to solve. So there's a couple of theorems we need to talk about first. If parallel lines are cut by a transversal, then our corresponding angles are going to be congruent. If parallel lines are cut by a transversal, our alternate interior angles are going to be congruent. If parallel lines are cut by a transversal, the alternate interior angles are going to be congruent. If parallel lines are cut by a transversal, then same side interior angles are going to be supplementary. And if parallel lines are cut by a transversal, then same side exterior angles are also going to be supplementary. So a way to help us remember this a little bit is that corresponding and congruent start with a C. Same side interior, same side exterior start with S, just like supplementary. So really the only one we need to work on memorizing is the alternate interior and alternate exterior, which should be different than the same side. So first we're going to look at a figure and determine what type of angle pair is represented and then what is the relationship between those. So in number one, we have the two angles. They're in the same position of their group of fours. So these would be corresponding angles. And corresponding angles are going to be congruent. In number two, we have two angles that are on the same side of the transversal, and they are between the lines that are parallel. So these are going to be same side interior angles, and their relationship is going to be supplementary. In number three, we have two angles that are on opposite sides of the transversal, and they are outside of their lines. So these are going to be alternate exterior angles, which are going to be congruent. In number four, we have two angles that are on opposite sides of the transversal and between the lines. So these are going to be alternate interior angles, which are going to be congruent. And in number five, we have two angles that are on the same side of the transversal and outside the lines. So these are going to be same side exterior angles, and those are going to be supplementary. So now let's look at some problems where we are going to solve using these ideas. So in number 6, we want to solve for x. So these arrows mean that the lines are parallel. These angles are same side interior because they are between their lines and on the same side of the transversal, which means they are supplementary. So we would have 125 plus x plus 15 is equal to 180. We combine like terms, we get x plus 140 equals 180. We can subtract 140 from both sides, so x is 40 degrees. In number 7, when we solve for x, these angles are in the same position in their group of 4, so they are corresponding angles, and corresponding angles are going to be congruent. So we have 110 is equal to 4x plus 10. We can subtract 10 on both sides. 100 equals 4x. When we divide by 4, x is 25. Now we want to solve for x and find the measure of angle 1. So when I look at the angles with x, they're alternate interior angles, which means that they are going to be congruent. So we're going to set them equal. 3x plus 17 is equal to 5x minus 43. Our first step then is we can subtract 3x from both sides. 17 equals 2x minus 43. We can add 43 to both sides. And we get 2x is equal to 60. We divide by 2, x equals 30. Now we're not done yet because we want to find the measure of angle 1. So angle 1 and this angle are corresponding angles. So what I'm going to do is I'm going to substitute in my x value. So 3 times 30 plus 17 is going to get us 107 degrees. Because angle 1 and 107 are going to be congruent angles, since they are corresponding, the measure of angle 1 is then 107 degrees. In number 9, when I look at my two angles, 10x plus 66 and 7x plus 12, they are same side exterior angles, so they are supplementary. 10x plus 66 plus 7x plus 12 is equal to 180. We can combine like terms. 17x plus 78 equals 180. We can subtract 78 from both sides. 17x equals 102. And then we can divide both sides by 17. And x equals 6. Once we know x is 6, we can substitute in, and we know that these two angles form a straight line. So we can subtract from 180. So 10 times 6 plus 66 is 126 degrees. So to get angle 1, I can do 180 minus 126. And the measure of angle 1 is going to be 54 degrees. In number 10, solve for x and y. A and B are parallel. So if A and B are parallel, we can add an arrow to both of them. We know that these lines are parallel. The other two lines then are transversal. So we have this blue transversal and the green transversal. If we are going to solve for x and y, we want to set up an equation for each transversal. So the blue transversal, those angles are same side interior, so we are going to set them supplementary. So 12x plus 32 plus 6y plus 40 is equal to 180. We can move the numbers to the other side by subtracting. 12x plus 6y is equal to 108. With the green transversal, these are alternate interior angles, so they are congruent. 6x plus 5y is equal to 62. So I can take both of these equations now and solve a system. 12x plus 6y equals 108, and 6x plus 5y equals 62. So we can multiply the second equation by -2. 12x plus 6y equals 108. Negative 12x minus 10y is going to equal negative 124. So we add straight down. Negative 4y is equal to negative 16. We divide. Y is 4. Once we know y is 4, we can substitute back in. 6x plus 5 times 4 equals 67. 6x plus 20 equals 62. We can subtract 20. 6x equals 42. Divide by 6. So x equals 7. So our solution would be 7